Okay, now that we've had a general overview of the full spectrum laser cutter and the Retina Engrave software, how to load our XPS in there and manipulate it and get it ready, let's go ahead and laser cut this vector. You will notice that I actually went ahead and added an extra layer. In this case, it's the red layer, and it's the outline, it's the border. And the reason I did that is I wanted to point out also that if you do happen to have a border that you want to keep for size purposes or parameters, or even if there is a layer on your creation that you don't want to have cut for whatever reason, you actually can go ahead and create it. And then if you notice, what I did is I simply took the passes down to 0 on that one. So even though the speed and the power say that it's at 100, with 0 passes, it's going to avoid that, but it actually kept basically the parameter, the size parameter, so that we could remain confident what size our cut will be made at. Okay, so now that we're all ready, we need to connect. If you notice down here, once again, there's no connection to the laser cutter. So I'm gonna come over to the laser cutter and turn on the power strip. And what this will do, and excuse the sound because you notice there's a number of plugs, that turns on the exhaust, and there's actually a pump that is pumping water through that tube to keep the laser cool, and then obviously the laser itself. So one flip of switch and our laser cutter is ready to go. You will see that there is actually a bead down on the piece of paper. There it is, that's our laser. So what we need to do now is come back to Retina Engrave, and we're going to connect. So we're gonna hit this button, this icon in the bottom left here. It's gonna search for the network. And if you notice, it now says connected, but we're not homed right there. So what that means is we need the laser to move up to the top right corner. That is its home. That is the laser cutter's origin. So again, we're going to use that icon of the home right up here in the software, and we're going to hit that. And in doing so, our laser is going to move to the top right. Now it's been homed, so we now see that it's indicated that it's homed, which now is all green. We're a go ahead, but we need to actually tell the laser where we want our origin to be. What it does is it will cut from the top left, moving across and moving down. So it's going to cut in this direction, ending in the bottom right, and then go back up to its starting. So we actually need to use these keys, these directional keys, to move I'm going to press on the left key, and if you notice, here we go. We're manually moving it. And let's zoom in there so you can see there's that bead. And let's say I want to get it right on the corner. Well, you notice on fast speed, you notice how it's really quick and rough going by. What I can do is I can hit this fast slow button. It's the bottom left button on our keypad, and that moves it to a slow XY. And in doing so, we have a great deal more precision. Notice how much slower this moves. Okay, so we can get that right to that top corner there, let's say. Okay, and now it goes back to idle. Sorry, we have some glare. Idle, it's good to go. Now lastly, and we can do this either before the laser's turned on or now. I wanted to show it to you while it's on. We want to make sure that the laser is at an optimal distance from our material. And the way we're going to do that is to use what's called a billet. And this is a 2-inch billet. And that's because we have a lens in our laser cutter that is maximizing the laser at a 2-inch distance from the material. So what we're going to do is we're going to slide this billet underneath the material, and how we do that is we're going to loosen it right here, and we're going to slide this up and slide the billet under, and then sit the laser on the billet and tighten it up. And there we go. And so now the laser is exactly 2 inches from our material, which is optimal cutting. And then we place the billet over here so it doesn't get lost. The honeycomb aluminum underneath obviously enables the laser to cut through without burning and without heating up whatever the material might be. So again, this is a heavy cardstock. We had our settings for that. So now our laser is where we want it to be for the origin. Lastly, let's go ahead and run that parameter check. This one here, actually the run job perimeters is called. And so by hitting that, if you notice, it's going to basically check our, let me run that one more time to show you. I don't know if we got a good view of it. So yes, it's on as we want it. So let's go ahead and go up to our play button and let's go ahead and start it. And if you notice, it's getting it ready and away it goes. Now we had selected our dotted line to be the first cut in this project. And the reason we actually did that is, so you can, I'm going to jump back over the software. If you notice, you can also specify the order of our cuts. And actually the red was the first cut, but because we had 0 passes, it skipped that one. And then the second is the dotted lines. And the reason we're doing that is we're having it do the internal cuts or the lesser cuts first, working its way out to the permanent full major cuts last, so that in the event that it did cut out the exterior, it wouldn't blow or move, because obviously with that, and there's that just slight etching of the star. So here's where it's cutting out in full. And if you did have the part cut out in full first, the exhaust or the vibration of the machine may move your blank just a little bit, to the point that those sketches or those dash lines or your star or whatever detail you may have may not work and may not be precise. So here we go. This is the box as it's being cut, and you see that because it's a vector, it's just tracing that line very, very quickly. And jumping back into our software, you see that the time countdown, less than 2 minutes left. So it's very, very quick. Also, lastly, on the software, you notice that here's the red dot showing us where the laser is going. And interestingly enough, there is not necessarily a rhyme or reason how it cuts. You would think it would be methodical in tracing the line segments in a methodical way, but it does not. It kind of jumps around, but ultimately gets all of them. So skipping ahead, this is basically what the final project would look like. Here it is, cut out. And this is actually the box as it has been made. And this is that raster of the Joker. And so we did it on a wooden blank. And again, in that much more time-consuming process, it went back and forth and cut that. And it turned out quite well. And the last piece I wanted to show you, wrapping this laser cutter tutorial up, is this is a really good visual kind of assessment of your speed versus power. Obviously, the higher the power and the lower the speed, the greater the cut magnitude. As you increase your speed and decrease your power, the less impact you're going to have. Now, this is going to vary material by material, so it is some testing. And Full Spectrum does have some guidelines on materials, but it really does depend even on the precise material. And there are some materials that actually have like metal flakes in them, and they won't cut at all. So I think ultimately proof is in the pudding. We need to get the material, a small sample of it, into the machine to test it, to see how well it works out and where we are going from there. So in that meantime, there's the final project. I can go ahead and turn off the cutter, and if you notice, the blank just pops right out, and we can remove the excess paper, fold that box, and we're good to go. So I hope you give the Full Spectrum Laser a whirl. It's a lot of fun to work with.